How does hazard reduction burning promote healthy species and ecosystem diversity? The purpose of prescribed burning is not actually to promote healthy species and ecosystem diversity. It's primarily intended to protect human life and property. Whether it's helpful or detrimental to other species has always been secondary to that. It's commonly observed that following fire there's a flush of life. The species richness or total number of species at a site often increases for a few years, then declines as the forest ages. On the face of that, we might think that prescribed burning is good for biodiversity, but it's not that simple. When we light prescribed fires, put bushfires out, light backburns, or start accidental fires, we affect the fire regime in that area. The fire regime is the frequency that a point burns, the severity of the fire, the season or time of day, and the spatial pattern of fires. When we change the fire regime, we give some species an advantage and others a disadvantage. The flush of new life straight after a disturbance is dominated by widespread common species that breed fast and die young. Over time they're replaced by others that are less common, slower breeding and longer lived. The species richness falls at that site, but less common species get the chance to live, and the more common live fast die young species find new patches of disturbance. Whether we're helping or hindering biodiversity depends on which species we're favouring. The timing of a fire also makes a big difference. If a fire burns in an area with wet winters and hot dry summers, then seeds germinated by the fire in autumn can get established before the next summer arrives. If they're germinated in the spring though, they'll probably die and the soil will lose that part of its seed bank. Koalas often move into shaded gullies in hot weather, so when a fire comes through, they're in the place least likely to be hit hard. If their habitat is burnt in cooler weather though, they'll be left exposed. Perhaps the fire will be mild enough to leave them untouched, but not necessarily. The spatial pattern of fires affects the capacity of animals to relocate and find food or habitat afterwards. If the burnt area is very large, or if areas of the right habitat are too far apart, they've got nowhere to go. Finally, the pattern in which we light fires makes a difference. Natural and Aboriginal fires tend to start from a point and spread outward or along with the wind, but when we light prescribed fires, we light up in multiple places at once. A standard approach is to light the edges of a block and burn inward, then light up the interior using aircraft. Animals attempting to escape are trapped. There are times that burns are termed ecological burns because certain areas are considered to be too long unburned. While it's possible, it's increasingly unlikely to be the case. Charcoal records across the country tell us that for the most part, fire frequency has increased dramatically since colonisation. With a changing climate, that's even more the case now. As a result, we have mountains of evidence about species disappearing due to frequent fire, but very little evidence that others are disappearing due to its lack. Remember, the purpose of prescribed burning has always been first and foremost to protect human lives and human constructions, not other species. Do we need to consider the impacts of ecosystems being repeatedly burnt by severe fire at a period less than the calculated ecosystem recovery period? Yes, if the survival of other species is important to us, then we need to consider frequent fire of all severity. A small animal or plant that can't escape may be in just as much danger from a low severity 1 metre tall flame as it is from a high severity crown fire. The difference is that the high severity fire will threaten more species at once and create more extensive change in the habitat. So, how do we prevent that from happening? Prescribed burning can reduce the severity of bushfires, but generally only when it's very recent. That comes at its own cost though. Prescribed burning leverage is a measure from mapped fire histories showing us how many hectares of bushfire can be prevented for every hectare of prescribed burning. Before we started measuring it, it was widely believed that bushfires not only stopped at the edge of prescribed burns, but that the burn left a kind of unburnt shadow behind it. The popular line was that we were lighting a small fire to stop a big one. We now know that's not true. The majority of even recent prescribed burns are reburnt when a bushfire comes through. Even in the most well-known leverage study that was conducted for southwest WA, they found that 4 hectares had to be burnt with prescribed fire to prevent 1 hectare burning in a bushfire. The reality turned out to be that prescribed burning is about lighting a big fire to stop a small one. Most of the area burnt in each prescribed burn will be burnt again when the next bushfire comes through. Won't it be less severe though? Perhaps, but that really does depend on the weather at the time. This is part of a prescribed burn I conducted some years ago when I worked in fire management. This is the same ridge 4 months later. At the end of a winter in the snowy mountains, there's now plenty of grass to carry a fire, and the growth season has just begun. This is the same ridge 8 months after the prescribed burn, burnt straight through by a crown fire. Now, even though it didn't work, that burn was in the right place to block a bushfire. Unfortunately though, you don't know when and where the next bushfire will come through, so you can't guarantee that. It may lie in the path of a bushfire 10 or 15 years later though, and that's a problem. This is an area of jarrah forest that hasn't been burnt for about 60 years. This is a patch of that same forest that was burnt by a small, low severity fire a few years ago. Notice the dense regrowth. This is an area of jarrah nearby that was burnt by a prescribed fire 8 years ago. This is that area after a prescribed fire last November. Satellite imagery shows that all except the edge of it burnt as crown fire. Why was it so severe when it was a prescribed burn? One reason is that the dense regrowth had made the forest as flammable as it could be. Prescribed burns make forests less likely to burn at high severity for a little while, but if the regrowth comes back thick, as it does in so many forests, then they're far more flammable for decades after. Climate change is certainly making fires more frequent and severe, but it's not the only thing driving that. Both the peer-reviewed fire behaviour models and the analysis of what has happened through history are telling us a consistent story. As more gets burnt, by us or by bushfires, we get a short period of advantage and a long period of disadvantage. It gives us a landscape like the one burnt through by the North Cliff Fire in southwest WA a few years ago. The old forest where the shrubs had naturally thinned has been burnt to produce a young forest, but the result is that most of the landscape is now in a state of dense, flammable regrowth. According to your presentation, waiting decades for the understory to thin out would reduce the hazard over the long term. However, in practice, it would be untenable to wait and do nothing. Are we now locked into a cycle of having to keep the system in the early stages of recovery? That is the risk that we run when we lose increasing amounts of long unburnt forest, particularly as the climate makes fire more likely. If that is the case, it would be disastrous. The only way to keep all forests under roughly a 5-year age is to burn 1/5 of them every year, effectively for good. That's what burnt last season. But no, I don't think we're at that point yet. Much of the Australian Alps used to have centuries between fires, while the various Ngaragu, Woggaloo and other nations were managing them. On the other side of the world, though, English and Scottish graziers were burning British forests so frequently that they cleared them and created the moors. Now, some of those graziers migrated to the Alps in the 1840s, and by the end of the decade, areas there were suddenly being burnt every 4 years. A century later, when it was virtually all in a state of flammable regrowth, the government of the time stopped any burning, and from then until the time I started in fire management there, no really big fires had occurred. Now, climate change has altered that picture, and the combination of drought, disappearing snow and massive dry lightning storms has repeatedly this century caused fires far larger than anything in the 50 years before. Despite that though, very large areas of the New South Wales Alps have only a few more years to go until they drop again dramatically in their flammability. What that tells me is that we're not yet at the point of no return. I think there is hope, and the next question touches on that. What practical solutions can be employed to protect forests from burning while allowing them to recover and grow to maturity to regain protective canopies? I can think of 4 steps at this stage to achieve this. 1. Stop burning and logging old forests. This past fire season followed a record decade of prescribed burning in New South Wales national parks, more than any other on record and more than twice the preceding decade. Even though the ABC fact-checked me when I pointed that out, a forestry lobby group still objected because they said that the statewide total had gone down. Think about that. The area of prescribed burning on conservation land doubled, but the statewide total fell. What that means is that much less burning has been done on private land or forestry land where the life and property is. Instead, remote conservation land, the old forests, was being burnt. Forestry practices such as thinning and clear felling affect flammability in similar ways, opening the canopy and promoting shrubby regrowth. Recent work has, however, shown that well-managed timber plantations can be low flammability. We need to change. If we're burning to protect assets, then we need to do it close to the assets and leave what's left of the old forests alone. Number 2, change our understanding of fire behaviour. On the left-hand side of this photo we have wet sclerophyll forest that hasn't been burnt for over 50 years. On the right-hand side is a fire that started at the peak of last fire season. The shrubs have been scorched, but the fact that none of them were burnt shows that the flames were shorter than their bases. As a result, it was easily contained using hand tools. Now, our traditional fire behaviour models have long told us that old forests are dangerous in a bushfire because of high fuel loads. As a result, we're less likely to aggressively fight fires there and more likely to fall back to a road and try to light it up as a backburn. There are times when old forests will burn severely, but there are also plenty of times this season when they burnt mildly and fire could have been contained with a rake hoe. We need to know with confidence when that will happen so that we don't miss the opportunities. Number 3, change our planning to make use of these natural advantages. Focus early detection and rapid suppression in old forests to both protect them as advantages and make use of their benefits. Number 4, finally, use a tactical withdrawal from our current situation. I suspect we can no longer get away with what was possible in the 50s when governments just stopped all burning in some areas. That will mean prioritising areas that we want to nurse through into maturity. The easiest places will be ones that are nearly mature, but we'll also need to identify areas that are important strategically. This is where prescribed burning may be helpful away from the urban fringe. Fires are easier to fight in young fuels than regrowth, so burns can be placed in areas where they can be part of a strategy to protect those areas into maturity. The critical thing here is that burning is only conducted where we're likely to put crews in place when a fire is coming through. If crews are not confident to face down a fire in that location, then don't burn there. Any extra hectares beyond this provide no strategic advantage and perpetuate the problem of too much disturbance, giving us a flammable landscape.